In this video, we will see how we can use square of a trinomial a plus b plus c whole square equals a square plus b square plus c square plus 2 times ab plus bc plus ca, and cube of a trinomial a plus b plus c whole cube equals a cube plus b cube plus c cube plus 3 times a plus b plus c into ab plus bc plus ca minus 3abc in problems based on DeMoivre's theorem. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. In the first problem, it is given that cos alpha plus cos beta plus cos gamma equals sin alpha plus sin beta plus sin gamma equals 0, and we have to prove that sin square alpha plus sin square beta plus sin square gamma equals cos square alpha plus cos square beta plus cos square gamma equals 3 upon 2. Since here cos alpha plus cos beta plus cos gamma and sin alpha plus sin beta plus sin gamma each equal to 0, from this given part we write which is given to be 0 plus I times which is also given to be 0 will be 0. Here we will rearrange the terms and write this cos alpha plus this I sin alpha plus etc. equals 0. If we assume cos alpha plus I sin alpha equals A, cos beta plus I sin beta equals B, and cos gamma plus I sin gamma equals C, then we get A plus B plus C equals 0. From this given part we also can write minus I times equals 0. Again rearranging the terms, we write this cos alpha minus I sin alpha plus etc. equals 0. By DeMoivre's theorem, this can be written as cos alpha plus I sin alpha raised to minus 1 plus etc. equals 0. Now as assumed up here, we write this as a raised to minus 1 plus b raised to minus 1 plus c raised to minus 1 equals 0. Now from a raised to minus 1 plus etc. we write 1 upon a plus 1 upon b plus 1 upon c equals 0. We first write LCM of a, b and c, abc. Now abc upon a is bc, bc into 1 is bc, etc. plus ac plus ab equals 0. By cross multiplication we get ab plus bc plus ca equals 0. Now we have square of trinomial a plus b plus c whole square equals a square plus b square plus c square plus 2 times ab plus bc plus ca. Now from the results that we have obtained earlier, we have a plus b plus c equals 0, and from this result ab plus bc plus ca is also equals 0. Therefore this a square plus b square plus c square will be equal to 0. But for a we have assumed cos alpha plus I sin alpha plus etc. equals 0. For each of these we apply DeMoivre's theorem and write cos 2 alpha plus I sin 2 alpha plus etc. equals 0. Let us rewrite cos 2 alpha plus I sin 2 alpha plus cos 2 beta plus I sin 2 beta plus cos 2 gamma plus I sin 2 gamma equals 0. We will rearrange the terms and write this cos 2 alpha plus this cos 2 beta plus this cos 2 gamma plus I times sin 2 alpha plus sin 2 beta plus sin 2 gamma equals this 0 we will write 0 plus I times 0. Now we will equate this real part with this 0. By trigonometric formula we have this cos 2 alpha 1 minus 2 sin square alpha. This cos 2 beta is 1 minus 2 sin square beta plus this cos 2 gamma is 1 minus 2 sin square gamma equals 0. This will be 3 minus 2 times sin square alpha plus sin square beta plus sin square gamma equals 0. That will be 2 into sin square alpha plus sin square beta plus sin square gamma equals 3, or sin square alpha plus sin square beta plus sin square gamma equals 3 by 2 as required. Now if we replace sin square alpha by 1 minus cos square alpha plus this sin square beta by 1 minus cos square beta plus this sin square gamma by 1 minus cos square gamma equals 3 by 2. This will be 3 minus cos square alpha plus cos square beta plus cos square gamma equals 3 upon 2. Therefore, cos square alpha plus cos square beta plus cos square gamma will be 3 minus 3 upon 2, which will be again 3 upon 2 as required. So we have proved here this sin square alpha plus sin square beta plus sin square gamma equals 3 upon 2, and cos square alpha plus cos square beta plus cos square gamma equals 3 upon 2. Continuing with this problem, the next two things that we have to prove are: first, cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha equals 0, and second, sin alpha plus beta plus sin beta plus gamma plus sin gamma plus alpha. From earlier discussion we have A equals cos alpha plus I sin alpha, B equals cos beta plus I sin beta, and C equals cos gamma plus I sin gamma, and A plus B plus C equals 0, and AB plus BC plus CA equals 0. So from this we write cos alpha plus I sin alpha into cos beta plus I sin beta plus etc. equals 0. This will be e raised to I alpha into e raised to I beta plus e raised to I beta into e raised to I gamma plus e raised to I gamma into e raised to I alpha equals 0, which will be e raised to I alpha plus beta plus e raised to I beta plus gamma plus e raised to I gamma plus alpha equals 0. This will be cos alpha plus beta plus I sin alpha plus beta plus this will be equals 0. Again, by rearranging the terms we can write this cos alpha plus beta plus this cos beta plus alpha plus this cos gamma plus alpha plus I times this sin alpha plus beta plus this sin beta plus gamma plus this sin gamma plus alpha equals, for this 0 we will write 0 plus I0. Now equating real and imaginary parts, we get this cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha equals this 0 as required here, and sin alpha plus beta plus sin beta plus gamma plus sin gamma plus alpha equals this 0 as required here. In the next part we will see how we can use quadratic formula to solve problems based on DeMoivre's theorem. For a quadratic equation ax square plus bx plus c equals 0, the roots of this quadratic equation can be given by a quadratic formula x equals minus b plus or minus b square minus 4ac upon 2a, where a is not 0. In the next problem, it is given that alpha and beta are the roots of the quadratic equation x square minus 2 root 3 x plus 4 equals 0, and we have to prove that alpha cube plus beta cube equals 0 and alpha cube minus beta cube equals 16i. We will solve this equation by using quadratic formula. So we have a equals coefficient of x square, which is 1, b equals coefficient of this x, which is minus 2 root 3, and c equals this constant term 4. Next we find b square minus 4ac, which is minus 2 root 3 whole square minus 4 into 1 into 4. That will be 4 into 3, 12 minus 16, which is minus 4. So square root of b square minus 4ac will be square root of minus 4, which will be plus minus 2i. Now by quadratic formula, we have x equals minus b plus minus b square minus 4ac upon 2a. That will be minus 2 root 3 plus minus 2i upon 2 into 1. That will be 2 bracket root 3 plus minus I upon 2. This 2 cancels and we get roots of the quadratic equation root 3 plus minus I, that is alpha equals root 3 plus I and beta equals root 3 minus I. We have alpha equals root 3 plus I, which we can write as 2 times root 3 upon 2 plus I into 1 half, which will be 2 times, for this root 3 by 2 we write cos pi by 6 plus I times, for this half we write sin pi by 6. So alpha cube will be 2 cube into cos pi by 6 plus I sin pi by 6 whole cube, which will be 2 cube into, according to DeMoivre's theorem, this will be cos of 3 pi by 6 plus I sin 3 pi by 6. So alpha cube will be 2 cube into cos pi by 2 plus I sin pi by 2. And on the same lines, beta cube will be 2 cube into cos pi by 2 minus I sin pi by 2. So alpha cube plus beta cube will be 2 cube into I sin pi by 2 minus I sin pi by 2 will get cancelled, and cos pi by 2 plus cos pi by 2 will be 2 cos pi by 2. But since cos pi by 2 is 0, alpha cube plus beta cube will be 0 as required here, and alpha cube minus beta cube will be 2 cube. This cos pi by 2 will become minus cos pi by 2, and minus I sin pi by 2 will be plus I sin pi by 2. So here it will be cos pi by 2 minus cos pi by 2 will be 0, and I sin pi by 2 plus I sin pi by 2 will be 2I sin pi by 2. But since sin pi by 2 is 1, this will be 2 cube into 2I, that is 16I as required here. We know that if alpha and beta are the roots of a quadratic equation, ax square plus bx plus c equals 0, then sum of roots alpha plus beta will be minus b upon a, and product of roots alpha beta will be c upon a. And we also know that if we know the sum of roots and product of roots of a quadratic equation, then we can find that quadratic equation, which means this quadratic equation, by a formula which is x square minus sum of roots into x plus product of roots equals 0. After putting these values, we write x square minus b upon a into x plus c upon a equals 0. We will simplify this to get the quadratic equation. So A being the LCM, we will multiply throughout by A. That gives us ax square plus bx plus c equals 0, which is the same quadratic equation as this. So in the next problem, we will see how these things can be used to solve a problem on DeMoivre's theorem. Now the problem goes like this. If alpha and beta are the roots of the quadratic equation x square minus 2 cos theta x plus 1 equals 0, then we have to find the equation whose roots are alpha raised to n and beta raised to n. In the given quadratic equation, we have a equals coefficient of x square, which is 1, b equals coefficient of this x minus 2 cos theta, and c equals the constant term 1. We find b square minus 4ac, which will be minus 2 cos theta whole square minus 4 into 1 into 1, which will be 4 cos square theta minus 4, which is minus 4 into 1 minus cos square theta, which is putting sin square theta for 1 minus cos square theta, it will be minus 4 sin square theta. So square root of b square minus 4ac will be square root of minus 4 sin square theta, which will be plus minus I 2 sin theta. Now by quadratic formula, the roots of this quadratic equation will be x equals minus b plus minus square root of b square minus 4ac upon 2a. That equals minus 2 cos theta plus minus this I 2 sin theta upon 2 into 1, which will be 2 into cos theta plus minus I sin theta upon 2. This 2 gets cancelled and the roots that we get are cos theta plus minus I sin theta. Therefore, first root alpha will be cos theta plus I sin theta, and second root beta will be cos theta minus I sin theta. Now the quadratic equation that we have to find out, whose roots are given to be alpha raised to n and beta raised to n, will be alpha raised to n equals cos theta plus I sin theta raised to n, which according to DeMoivre's theorem will be cos n theta plus I sin n theta. Similarly, beta raised to n will be cos n theta minus I sin n theta. Now, sum of roots will be alpha raised to n plus beta raised to n. That will be cos n theta plus cos n theta 2 times cos n theta, because I sin n theta minus I sin n theta will be 0, and product of roots alpha raised to n into beta raised to n will be cos raised to n theta minus I square sin square n theta. And this is according to the identity a plus b into a minus b is a squared minus b squared. This further will be cos square n theta. This I square being minus 1, it will be plus sin square n theta, which is 1. So the required quadratic equation will be x square minus sum of roots into x plus product of roots equals 0. That will be x square minus this 2 cos n theta plus this 1 equals 0. So this is the required quadratic equation whose roots are alpha raised to n and beta raised to n. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.